Ever been bored during your day job working with FPGAs? Well, our game Puck is the perfect game to help pass the time. Puck is a single-player rendition of the classic game Pong. The point of this game is to volley the puck between your controllable paddle and the wall. With each additional volley, the ball moves quicker, causing the game to get increasingly harder as you get more volleys. This is the perfect game to quickly and easily pass time and have fun. However, with that aside, let's get into the code it took to create such a game.
Hi everyone, my name is Vikram and I will be explaining the code in the pixel file. So first we have defined all the main input variables and the output variables. So the input variables are clock, reset, up, down, video on, X and Y. And the output variables are RGB and score keep. So the clock is the clock input, the reset is the reset condition, up and down are the movements of the paddle. Video on variable checks whether the display is happening or not. The X and Y variables check the position of each pixel. The output RGB shows the color of each component of the game, and score keeps track of the score. So first we have defined all the boundaries of each of the components, and we've declared the initial speed of the puck. Then using an always block and if else statements, we've defined the reset conditions. So if reset begin, then that means that if the reset variable is equal to 1, then it will set all the variables back to its default original initial value, which is 0. And otherwise, if reset is not equal to 1, that means like either the user did not miss the puck, that means the paddle and the puck have collided, or the user has not pressed the reset button, then the values keep updating. After below that, we have used another set of if statements to increase the speed counter when the puck collides with the paddle. So whenever the puck collides with the paddle, then the score will increase by 1. Below that, we have defined the boundaries and the shape of the puck, and below that we have assigned a color to each component of the game.
Hi everyone, my name is Prashast and I'll basically go over some of the core logical components of the game. This code is basically about paddle movement logic, and it's in an always loop, and the first line is basically when no movement happens, so paddle stays at the same place. And then we do an if statement about the refresh tick, or it basically gives us the time constant for when the VGA is in sync with the VSync and the HSync, and it should refresh the frame. And then it's basically a logical block about it, with if statements and else if statements, and it has the first one is about moving the paddle up. So if the paddle if there's frames between the top part of the screen and between the paddle, if there are sufficient frames for the paddle to move, it would move up. And the same logic applies with moving down as well. And the ball left, ball top, and ball right, and all of these ball variables that you see are basically about the ball position and the top, the bottom, and the left and right components of the ball. Now moving on to the next piece of code. This code basically dictates the pixels within the ball and the boundary of the ball. So the square ball active variable is just basically checking the pixels within the ball boundary, and then we are trying to access the ASCII ROM that we have created for the ball, and then the ball active actually checks if that pixel has a value of 1 in the ASCII ROM and it is within the pixel of the ball. And then the last variable, the ball pause x next, decides that if there is a refresh tick that we got from the VGA controller, then it changes the velocity, x and y velocity of the ball.
Now we move on to the debouncer. The point of a debouncer is to make sure your button input signal is clean from interference. Essentially, it helps ensure the computer is recognizing the correct button input, especially when you're switching between buttons quickly. What is happening in this code is that for every positive clock edge, the counter is incremented by 1 until it fills the 3-bit value of 7 clock edges, which is equivalent to 70 nanoseconds for the 100 megahertz clock. When finally it recognizes this button as a true input. However, if the button input matches the clean signal, the counter is then reset to 0, making sure the short button is not inputted into the signal. The purpose of the VGA is essentially generating signals required to display images onto the screen. This includes coordinates, timing, etc. The VGA starts by first defining the resolutions to be 640 by 480. This is also known as 480p. Additionally, a 25 megahertz clock signal is required for the VGA, so it divides our existing 100 megahertz signal by 4. Vertical and horizontal counters are implemented to count each pixel on the display and give positions of those pixels, whereas the H-sync and V-sync tell the system when to refresh the rows and columns. Video on tells us whether our display is actually on right now and is only functioning when the pixels are being displayed within our 480p resolution. Finally, we move on to the top module. This module instantiates all our previous files to be combined and work with one another. The debouncer is instantiated for every button press to ensure that each button is clean. Next, the VGA handles all the timing and signals being received through our FPGA. Pixel is the most important file as it uses coordinate variables to know what it should be displaying on the screen, as well as processes for the inputs and score. Reg RGB is refreshing the color of our pixels at every rising clock edge. In the constraints file, we start by activating our clock. Next, we activate all the LEDs to display score by a bitwise manner. Next, we implement button up to move upwards, button down to move the paddle downwards, and the center button to reset our system. Finally, all the VGA pins are made active to allow our code to display on screen.
Hi, my name is Junse Lee and I'm going to demo our project right now. As you can see here, there's a yellow puck that player have to bounce it back. And the puck bounces back from many objects in this screen. For example, the left side wall, the top and bottom wall, and the pedal. If the puck hits the right side wall, it will just game over and it will reset the score indicator and the increased speed. As you can see here, you can move the pedal with the buttons in the FPGA. And the puck gets faster as you bounce it back. As you bounce back the puck with your pedal, it will increase the score and it will indicate here like this.
Doesn't work, we'll just put this is what you do to get the game to work, so we can say like, you reset your game.
That's technically it is like what is gonna be wrong.
Okay.
Because in the README, if someone wanted to like work on it and like let's say add on to ours, in the future they'll be like, okay, this is what we have to
Alright, cool.
like, fix these things that I probably gonna change this thing twice. Okay. Why do you make it 3 twice?